For week 2 of Project 4, we are going to be learning about simple machines. Please read these instructions with your child. Week 2, what is a simple machine? Activity 1 and Activity 2 are activities that must be done with your students. Activities 3 and beyond are optional, but we ask that Activity 1 and Activity 2 be completed for a grade. Activity 1 is the Simple Machine Station Guide. Students with your grown-up build and explore all 6 of these simple machines. As you build each one, write down what you see and answer the questions. The first simple machine is a lever. Make a lever out of the list of materials and explore the relationship of the fulcrum to the load. What happens when you move the fulcrum closer to the load? Write down what you see. Move the fulcrum away from the load. Write down what happens. You are going to need a wooden ruler, an object to lift, tape, a can or toilet paper roll, and a lever. The fulcrum is your base. That will be your can or toilet paper roll. Your lever is going to be a wooden ruler or a stick with a flat side, 2 flat sides. You will need an object to lift, which is your load. That could be a penny, a dice, a small car. And you will write down in your notes below here what happens when you move your fulcrum or base close to your load. Write down what you see, and then move the fulcrum away from your load and write down what you see. The second simple machine is the inclined plane. You are going to make inclined planes with boards or cardboard and change the slope of the board. So to do that, you are going to need 2 boards or cardboard in varying lengths. You can make your inclined plane with one of your boards a gentle slope, which could be your cardboard resting on top of a remote control. Your steep slope could be used by resting your piece of cardboard on top of a stack of books to create a steep slope. After you've made your inclined planes, you are going to put rubber bands around a book. Tie a string to the rubber bands and pull the books up the different inclined planes. Which slope was hardest? Which slope was easier? Which slope stretched the rubber bands the most? Also try to pull the book straight up without using the inclined planes. Answer your questions below in the notes section here. Which slope was hardest and which slope was easier? Which slope stretched the rubber bands the most? The next simple machine that you're going to look at is the wheel and axle. Use one of the inclined planes that you created above. Put the ruler on the side of the inclined plane to measure how far each car travels. You're going to place one of the cars on its side and let it slide down the plane. How far did it go? Place the other car on its wheels. Let go and let it slide down the plane. How far did it go? Write down the distance each of the cars traveled. What did you notice? So you will answer your questions here on how far each car traveled and what you noticed when it was on its side and when it was on its wheels. The next simple machine that you will look into is the screw. Make a screw out of an inclined plane. So you're going to need a 9-inch paper square, tape, pencil, scissors, and a tabletop. You're going to make a screw out of an inclined plane. You're going to cut the square, the 9-inch paper square here, you're going to cut it diagonally to make 2 triangles. Tape one of the short edges of the triangle to a pencil. Wrap the triangle around the pencil. You will actually see the inclined plane as part of the screw. Answer these questions in writing. What is the screw made out of? How did you make an inclined plane with the given materials? The next simple machine is the wedge. Cut paper with both sharp scissors and dull scissors. How can the cuts be different when using a wedge? Which was easiest? Why do you think there is a difference? You're going to need paper, dull scissors, and sharp scissors to look at how a wedge is used. The wedge would be your scissors, and this would be your paper. When you're cutting with your dull scissors and your sharp scissors, how can the cuts be different when using the wedge, the scissors? How are they different with dull and sharp scissors? What is easiest? Which one is easiest to use? And why do you think there is a difference between dull scissors and sharp scissors? Answer those questions below here on the notes. The next simple machine is the pulley. Make a pulley with a sewing spool, string, and a pencil. Use this pulley to lift an object. Compare lifting the object with the pulley and without the pulley. Which was easier? Why do you think there is a difference? The materials you are going to need to make a pulley is a sewing spool, which is a spool of thread. So your grandma or your mom or your uncle or dad or somebody who sews will have a spool of thread. You're going to need one of those. You're going to need string, a pencil, and an object to lift. You're going to use the pulley just how it shows in the picture, as this would be your sewing spool. This would be your string. This would be where your pencil would go. I guess you would tie the string onto the end of your pencil, and then you would find something to lift. And you would see how, when you pull the string, how the pulley works. And lift objects with a pulley and without, and then tell us what is easier and why you think there is a difference. Next, if you have access to the internet, you can watch 2 or more YouTube videos showing these simple machines in action. There is the Rube Goldberg official website, and there are some YouTube videos here showing more of Rube Goldberg's simple machines and ideas. The activity 2 is also required for grade in this part of the project. We are going to read about the man who put these simple machines together to make silly, interesting, simple, and complex machines. We are going to meet Goofy Rube Goldberg. Read the story below about Rube Goldberg. There are also some movie examples that show Rube Goldberg machines. I'm sure you've heard of The Goonies, Edward Scissorhands, Home Alone, Back to the Future, Honey, I Shrunk the Kids, Toy Story's Buzz Lunch, The Things You See in Robots, and Wallace and Gromit and The Curse of the Were-Rabbit. Those are some movie examples that have some Rube Goldberg machines in them. So for this activity, there are 6 simple machines that are found in many of Rube Goldberg's machine designs, which we learned about in Activity 1. How can you use 3 or more in your own design? Maybe you can use a screw or an inclined plane or a pulley or all 3 of them to make something new. Draw your own design ideas to create a drawing of your own Rube Goldberg machine design. Here are some examples of a design that uses 3 or more simple machines to do a simple task. So the machine is how to sneeze. So if you see here, you can see that we have a lever in action, we have a pulley, and we have a wheel and axle, an inclined plane. The mouse jumps into the barrel of apples. An apple gets knocked out of the wheelbarrow. The apple falls into the bucket. The pulley releases and drops the apple down to the lever. The lever drops and flips the feather at the nostril. The feather tickles the nostril and makes me sneeze. Achoo! So there's an example of a design that uses 3 or more machines to do the simple task of sneezing. There is also the simple fly swatter by Rube Goldberg. You can read this here. A safe falls on the head of Professor Butts and knocks out an idea for his latest simple fly swatter. And if you read this and look and see, you have the letter A, so this is where it starts. And it goes to B, C, then goes to D, shoots here, goes to E, down to F, shoots all the way over to G. I don't see H. Oh, down here to H, I, J, K, L, M, N, and boom. Swats the fly with the shoe at the end. So yeah, that's the many different simple machines used together to create a fly swatter. For extra credit, if you want to build your own Rube Goldberg machine design and record it, you'll get 20 extra credit points. Don't forget to ask your parents to share your video with your teacher for your points. Try to put together at least 3 simple machines to create a chain reaction. So these are the additional activities. They are not required, they are optional. It is extra work if your child wants to continue learning about simple machines and more science terms, and you may read through those activities. Here is a glossary of the terms that are used so that if there is a word in there that we may not understand, you can look it up here. Fulcrum, the point on which a lever rests or is supported and where it moves. So yeah, really helpful information here in the glossary. And then this project will be graded. We are going to observe student ideas, progress, and teamwork, and their understanding of kinetic versus potential energy. Not every activity needs to be done in this lesson. Your parents and guardians may choose what is appropriate for you, their child. If you need any help, please do not hesitate to reach out to your teacher, as we are here to help you as we explore the simple machines.